Welcome everyone, and today let's talk about Mobileye and their redundancy system because I thought it was really interesting. When people say they have redundancy in place, they have a LiDAR and a camera, etc., they don't really mean redundancy, they mean sensor fusion. So I don't know what I'm floating here, but let's move on to the four types of redundancy we can have in an autonomous vehicle and that Mobileye implements. Number one is sensor, okay? This is the one that everybody talks about, sensor redundancy. Camera versus LiDAR versus radar, sometimes imaging radars. This idea of having multiple sensors, not depending just on LiDAR or just on vision, it's a kind of redundancy if it's not assimilated to sensor fusion. Number two is the system, okay? We have ways to do self-driving cars. We have the modular way, which will be like having perception, localization, planning, control, and we have the end-to-end way. So I'm going to talk about that as well. Then we have the method, like how do you want to differentiate between, let's say, objects in a point cloud or between pixels in an image. You could do it with geometric ways or with appearance features, stuff like that. And finally, we have the algorithm base. Do you want to use model traditional techniques or learning techniques? Okay, so let's see that. Let's see these four pillars, these four, let's not call these pillars, let's try and call them the axis of redundancy in self-driving car. Starting with the sensors. So many company implements sensor fusion. And when they do it either with early fusion, for example, which would be fusing the point clouds with, let's say, an image or maybe a semantic mask into a LiDAR point cloud. It could be mid fusion, so they would first process into some kind of CNN features, maybe voxels with 3D CNNs or point nets, and then they would fuse the intermediate features. Or it could be late fusion with some kind of objects being fused, the bounding boxes in 3D that you would fuse. And you also have this type of cross fusion, which I talked about with my community last month, which is more about fusing, let's say, one stage, for example, early fusion with late fusion, or maybe mid fusion with late fusion, doing some kind of fusion maybe early on, then later, etc., and fusing that. Okay, so obviously, when you're going to do fusion, here you're going to fuse raw data, here intermediate features, here are some objects, and there you're going to do a mix and match of everything. Mobileye doesn't do that, okay? They don't really use this sensor fusion thing. What they use instead is a different approach, where they're gonna have, for example, a vision-only system, then they're gonna have a system that implements sensor fusion between LiDAR and camera, and then they're gonna have a system that depends, for example, only on LiDAR. And they're going to have these three systems, and in the end, fuse these systems into a policy. So it could be identified as some kind of late fusion, but it's more like a combination of outputs or a voting majority system that's going to decide, and that is redundancy, okay? So when you have camera and LiDAR, let's say these are two good sensors, but and when you have the true redundancy, you don't have just a fusion of this, you have these two actively working, and then these two either confirming or contradicting each other. The second thing would be the system thing. Okay, so when you have the system, you have in general two ways to do self-driving cars. The first type is the four-pillar architecture, and the second time is the end-to-end architecture. So the four-pillar one is going to be the modular approach. So it's very explainable, and when you drive, it can feel a bit robotics-like because you're just, in a way, following orders, like you're moving, then you're stopping, then you're moving, then you're stopping, etc. On the other hand, the end-to-end approach is a more direct approach. Like you have the input, and then the neural network directly outputs the trajectory. And since it's based on imitation learning, it can feel much more human-like. The counterpart is that some people call it a black box. Now, we have ways to visualize inside the black box, but it's still something where you don't really control exactly how you would like something to happen. If you want a car to brake at red light, you would need to show it examples of braking at red light. You would not program it to stop at red light. Okay, so the four pillars is really perception, localization, planning, and control. And on the other hand, you have the sensors going to perception, then you have some GPS maybe, so localization, and then some car parameters for the control because each controller is unique. And then you have the output, which is just the steering and the throttle. Now in an end-to-end system, you still have all of these things, but sent to a network that's going to then implement steering and throttle. Okay, so we have the sensor, we have the system. Now I want to see the method, and then we'll see the algorithms. So the method now. When we're talking about perception, it's not just always the same thing. Object detection, for example, is much more than just bounding box detection. For example, you could look in an image into the appearances, you could look at the visual features, you could look at stuff like that. But you could also construct a graph with the features, you could also look at the geometry, or if you are in a LiDAR, you could look at the actual geometry, right? The actual shape that the point cloud has. And that is very different. There is this fantastic video from Oxbotica, which I'm going to use as a purpose to just show, let's say you want to drive but just stop if there is an obstacle that is, let's say, above the flat surface, above the ground. You could just select in a region of interest everything that is just standing above the ground, right? And so when you're doing that, you're just trying to have some kind of safety feature where you just say, okay, if there is something above the ground, let's put it in highlight, and then let's just break if it's in our way, okay? And for example, when you have things like a palette that maybe your model is not trained on, then it can be very useful if you just detect something, just a point, just a geometry, just a shape, okay? On the other hand, the appearance feature would require to classify it, or to at least linearly or with deep learning, but to classify it, right? And that calls for the last thing, which is the use of deep learning or not, okay? So for example, this is a video from Innovis Technology, so I recorded it there, and basically they have all these object detections algorithm on LiDAR point clouds, and it's their LiDAR, and it's really very cool LiDARs. When you go there, it's like mind-blowing to see, like there is this LiDAR here, and this one, and this one, and they tell us, they told me something like this one is for 2026, something like that. So it's like 3 years from now, and so 2 years from now. But you see the point. Like it's they have a really long-term vision on their sensors, and this algorithm that I showed you is not based on deep learning. At least I don't think they told me it was based. I think they told me it was based more on the classic approach with some kind of mathematical models showing what. A car should look like, okay? As opposed to what I teach in my courses, which would be more the deep learning approaches, something like that, right? Which is more like using point voxel, CNN approach, etc., etc. Okay? So when you think about redundancy, you don't think about just one type. You have to think about doing 2, maybe 3 or more of these things. And today, it's possible today to run an end-to-end system side to side with a modular approach and just compare the two, okay? It's possible today. It was not really possible in 2017 because the computations were too heavy and it was already hard enough like that. But today you can do something like that. So let's see some examples. For example, with system redundancy, okay? So here it's really modular versus end-to-end. And you can see a big difference is that when you're doing the modular thing and you're looking at the camera, you're really looking at the camera features, right? You're looking at in the camera space. But when you're in the end-to-end plane, you kind of have to fuse all the cameras together and have the bird eye view. So you're automatically in the bird eye view when you're doing the end-to-end. Now, end-to-end does not mean you don't have bounding box detection or lane line detection or things like that. It just means that you can extract this from the model, but this is not the outcome of the model. Okay, now a sensor redundancy. So this is a classic one. You have a camera with, every time we have geometry, okay, so really the shapes of the objects. We have a model-based approach. So this means not, when I say model, it's more mathematical model. So let's call it classical approach. And you have a modular approach, okay? And on the other hand, it's exactly the same, but with point cloud. So you're really processing the point cloud, the shapes, looking at maybe clustering, etc. The only thing is that there is a LiDAR versus a camera. And you can see in the camera space, sometimes you don't even need bounding boxes to detect that there is an object in front of you, right? And then you can see all this type of redundancy. The only thing that is in common is that it's both using deep learning, right? So I want to say that object detection really is not just about bounding boxes. And let's say an example that I called in a Mobileye talk on YouTube about their stealth technology. And they said, let's say we have to detect lane lines. And let's say you're the guy in the middle that tries to do something and it's very complex. They have, what if the lane line detection fails, right? It's very, very problematic here if you're not centered in your lane line. So they have what they call the primary Gaussian fallback system. And it involves this. First, you're going to use a lane line detection system. And everybody stops there. Okay, we have our lane line detection. It's over. But if this fails, what are you going to do now? That's complex. And this is why they also have, for example, the second system, which is HD map extraction. So you're going to take the HD map and you're going to, or in their case, the REM map, and they're going to put that into your current driving position, and you're going to position yourself, and then you have your lane lines, right? Because you know where you are, so you know there are lanes where you are, and if you locate right and you have a map, you can technically just know where the lane lines are. It's like being blind, but just knowing the road. And the other way would be, for example, if you have an end-to-end system, you're just going to extract the lane lines in a second approach, in a parallel approach. So the first one maybe is lane line detection in a modular way, and the other one is in an end-to-end way. And you can just extract these two and then do some kind of majority voting algorithm. Or in their case, I think they had one that they trust the most, and then they have a fallback. And if the fallback doesn't, so let's say the one that they trust the most is lane detection. And then they're going to compare that with the HD map extraction. And if the HD map extraction says, oh, no, this is not the same thing, this one is 2 centimeters to the right, everything is wrong, then they're going to look at the end-to-end system, and this end-to-end system is going to be the one that confirms everything, okay? So now, if you want to learn more about all of this, at Think Autonomous, I talk mostly about all this advanced stuff. I try to break the myth that when you learn object detection, you become a self-driving car engineer. Okay, this is not true. And even when you learn object detection, it's not only about bounding boxes. Okay, so now at Think Autonomous, we are having the daily emails, which I highly invite you to join. And we're now launching an app very soon with the clients will have all their content on it, and there's going to be a lot coming in the next few months, including an end-to-end learning course at the end of the month. So stay tuned and visit Think Autonomous and join the daily emails if you want to learn more.